Hey YouTube fans, in this video we're going to look at a couple of examples of how to use the second derivative test. Let's do it. So we have to find the relative extreme points of each function using the second derivative test whenever possible. The first function is f of x equals x cubed minus 3x squared minus 2. Alright, so first let's find the first derivative and the second derivative. Now let's find the critical points. Remember that these are the points that make my first derivative 0 or when the first derivative is undefined. We set the first derivative equal to 0 and then we can factor. From our first factor we have the solution x equals 0. And from our second factor, we have the solution x equals 2. Notice that there are no points for which the first derivative is undefined. Now to apply the second derivative test, we have to evaluate the second derivative in our critical points. We can use the calculator for this example to make this part a little bit easier. So I'm going to show you a little trick. We can use the calculator to graph the function. So we can save the equation in y1. And when we look at the graph, we can already see where the maximum and the minimum is. But not every function is going to be so easy because we don't know in what part of the domain we're going to find the extrema. So let's use the second derivative test here. Okay, so we're going to use the derivative of the derivative in order to evaluate our critical points. Now we could type in our function at this point, but remember that we already have it saved in y1, so we can use the vars menu in order to plug in y1. Remember, y1 is where we plugged in our function. Here we get a negative result, so we know that the function is concave down. And our second derivative test tells me that we have a maximum at this point. Here we get a positive value, which means that the function is concave up, and we know from the second derivative test that we have a minimum at this point. Okay, now let's look at part B. We're going to do the same exact process, finding the first derivative and the second derivative first. Now we can find the critical points by setting the first derivative equal to 0 and solving. We can use common factor here, and then we can use the difference of squares. Our three factors give us the solutions x equals 0, x equals 1, and x equals negative 1. Okay, we're going to use the calculator to evaluate the second derivative at the critical points. For this problem, I'm going to use the Casio calculator just so that you can see the process in both calculators. For our first critical point, we can see that the second derivative test is inconclusive. For x equals 1, we see that the function has a local minimum. For x equals -1, we see that the function has a local maximum. Okay, now what about the point where it's inconclusive? Well, we have to analyze the first derivative. Let's see the possible sign changes that we have with a sign chart. We see that the first derivative is negative to the left and to the right of the zero. That means that there is no sign change. So we have no maximum or no minimum in this point. Okay guys, that's it for this video. Keep practicing and see you next time.